Nikolai Kucherenko does not look up when the shell hits the wall outside. He is 31 years old, standing in a factory in the Ural Mountains in December 1941, and the building around him is so cold that the breath leaving his mouth turns white before it reaches the blueprint in his hands. The temperature inside the Ural tank plant in Nizhny Tagil has fallen to -22°C, -8°F. The overhead cranes have stopped moving because the hydraulic fluid in their lines has thickened to the consistency of cold honey and will not flow. 3 of the welding machines on the floor below him have cracked overnight, not from enemy fire, from the cold alone, and the steel plates waiting to be assembled into tank hulls have frost on their edges thick enough to run a fingernail through. He has been awake for 31 hours. He knows because he counted them. He is holding a drawing of a tank that the Soviet Union desperately needs, and he is trying to work out which parts of it he can simply remove. Outside, 4,000 kilometers to the west, the Wehrmacht is within sight of Moscow's suburbs. German reconnaissance units have reported seeing the spires of the Kremlin through their field glasses on clear days. The Soviet state is not losing the war. It has, by most reasonable calculations, already lost it. And the only question left, the only question that matters to Kucherenko and the 5,000 workers shivering on the floor below him, is whether a tank factory in the Ural Mountains can answer the question that every army and every general and every politician in history has eventually been forced to face. Not how do you build a better weapon, how do you build enough of them? The T34 that existed in 1941 was, by any technical measure, a remarkable machine. When German panzer commanders first encountered it during Operation Barbarossa in the summer of that year, their after-action reports carried a tone that was unusual in Wehrmacht documentation. Something close to alarm. The T-34's 76mm gun could pierce the armor of every German tank then in service. Its sloped hull, 45 degrees on the front plate, caused shells to glance rather than penetrate, giving it effective protection far beyond what its actual armor thickness suggested. Its wide tracks distributed its weight across soft ground that swallowed German panzers whole. General Heinz Guderian, the architect of German armored warfare, wrote in his personal diary after the first engagements that the T-34 represented a complete surprise and that his men had no adequate answer to it. That was in July 1941. By December, the Soviet Union had lost so many T-34s that the model's theoretical superiority had become almost irrelevant, not because the tank was flawed, because the factory building it had been physically dismantled and moved. In October 1941, as German forces drove toward Moscow, Stalin issued the order that would define the entire Eastern War. The Soviet Union's industrial heartland would be relocated east of the Ural Mountains, beyond the reach of the Luftwaffe's bombers, beyond the reach of the Wehrmacht's tanks. What followed was one of the most extraordinary feats of industrial logistics in human history, and one of the least discussed. In the space of 3 months, the Soviets moved over 1,500 complete industrial enterprises, factories, machine tools, entire production lines, east by rail. The Kharkov locomotive factory, which had been building T-34 hulls, was loaded onto 8,000 railway wagons and transported 2,000 kilometers east to Nizhny Tagil. Workers rode with their machines because there was no one else to operate them when they arrived. Some of those workers died on the journey from cold. The ones who survived stepped off the trains and began assembling production equipment on open frozen ground before the factory buildings around them had been completed. They worked under open sky and temperatures that cracked cast iron. They worked because stopping meant the Wehrmacht reached Moscow, and reaching Moscow meant the war ended in a way that left no one in that factory alive. The first T-34 rolled out of the new Ural tank plant in December 1941. By then, Kucherenko already knew it was not enough. The tank took 3,000 man-hours to build. Germany was producing tanks faster than Soviet losses could be replaced. The gap was not closing, it was widening. And standing in that frozen building, holding that blueprint, Nikolai Kucherenko made the decision that would change the war. He began to cross things out. The men who built the T-34 before the evacuation were trained machinists working in established factories with precision equipment and time to use it. The men and women, and many of them were women, and many of the rest were teenagers, Working in the Ural tank plant in December 1941 were farmers, clerks, students, and teachers who had been handed a wrench 2 weeks earlier. They could not execute the fine machining tolerances that the original T34 design demanded. They could not produce the precisely ground transmission components that the original specification required. They did not have the equipment, the training, or, frankly, the time, because Kucherenko could hear the German guns in his imagination every single night. And he knew that every day that passed without a tank leaving this factory was a day the Wehrmacht spent closing the distance to the Ural Mountains. So he did something that no weapons engineer is supposed to do. He made the tank worse, deliberately, precisely, with complete understanding of what he was sacrificing and why. The original T34 used a complex 4-speed gearbox that required exact tolerances to function smoothly. Kucherenko replaced it with a simplified 5-speed unit that any machinist with basic skills could produce. It was harder to operate. Drivers complained that changing gear required the physical effort of a man wrestling with a fence post in frozen ground. It wore out faster. It broke down more often. Kucherenko knew all of this and signed the drawings anyway because this gearbox could be produced by workers who had been metal workers for 3 weeks, and the original could not. The hull welds, which in the Kharkov design had been smooth and consistent, because they were executed by experienced welders following precise specifications, became rough and irregular in Nizhny Tagil. Visibly so, thick ridges of weld material that any German tank inspector would have rejected on sight. Kucherenko left them. The weld held. The weld was the only thing that needed to do. The turret casting process, which originally required multiple stages of precise finishing work, was simplified to the point where the interior surfaces were left rough. If you put your hand inside a 1942 Ural T34 turret, you would cut yourself on the edges. Nobody was putting their hand inside a 1942 Ural T34 turret. They were putting shells into it and firing them at Germans. The production time per tank dropped from 3,000 man-hours to 3,700 hours, briefly as the new workforce learned, and then fell off a cliff. By mid-1942, the Ural tank plant was producing a T-34 in under 1,700 man-hours. By 1943, some assembly lines had driven that figure below 1,200. The Soviets had not discovered a shortcut. They had discovered something more powerful than a shortcut. They had discovered that perfection is the enemy of production, and that in a war of annihilation, production is the only thing that ends the war. If this story is new to you, subscribing takes 3 seconds and means you will never miss one like it. Production numbers tell the story with a bluntness that no rhetoric can match. In 1941, Soviet factories produced 3,016 T-34s. In 1942, after Kucherenko's simplifications had spread across every plant feeding the Red Army, Soviet industry produced 12,553. In 1943, the year of Kursk, the year the war turned permanently, 15,821 T-34s rolled out of Soviet factories. Germany, during the same 3 years, produced approximately 4,000 Panzer IVs, and had only just begun delivering the Panther, the tank specifically commissioned to counter the T-34, in numbers too small to matter at the scale the Eastern Front demanded. The ratio was never close. At Kursk in July 1943, the Red Army fielded 3,600 tanks. The Wehrmacht fielded 2,700. That gap had not existed in 1941. Kucherenko's pencil had created it. The German reaction to the simplified T-34s they captured and examined was one of the more illuminating episodes of the entire war. German tank engineers who inspected captured Ural-built T-34s in 1942 noted the rough welds, the coarse interior finish, the imprecise tolerances with what surviving reports suggest was genuine bewilderment. Their technical assessments identified the quality reduction with precision and concluded that Soviet manufacturing had deteriorated significantly. What those assessments missed, what the entire German armaments philosophy made it nearly impossible to see, was that the quality reduction was intentional, controlled, and the single most strategically significant engineering decision made by either side in the entire conflict. Germany's response to the T-34 problem was to design the Panther, a more complex, heavier, more mechanically sophisticated vehicle that took 150,000 man-hours to produce and broke down so frequently during its early deployment that at the Battle of Kursk, hundreds of Panthers were lost to mechanical failure before they ever engaged an enemy tank. The Soviets' response to the same problem was to decide that good enough, delivered in overwhelming numbers, defeats perfect, delivered too late and too few. The Panther weighed 44 tons to the T-34's 31. It carried 110 millimeters of front armor to the T-34's 90 millimeters. Its long 75 millimeter gun was, in terms of raw penetration figures, superior to the T-34's 76 millimeter at range. On paper, the Panther was the better tank. On the fields around Kursk, Prokhorovka, and the Dnieper crossings, the Panthers burned beside the T-34s they had theoretically outclassed, and the ratio of burning Panthers to burning T-34s told a story that no specification sheet could capture. For every Panther Germany completed, the Soviet Union completed 7 T-34s, 7 chances to put a round through a Panther's thinner side armor, 7 opportunities for one of those rough-welded, crudely finished, imperfectly machined machines to do the one thing it needed to do. The legacy of Kucherenko's decision lives in a number that historians still find difficult to absorb. Over the entire course of the Second World War, the Soviet Union produced approximately 57,000 T-34s across all variants. Germany produced roughly 6,000 Panthers, its primary heavy-medium tank, from 1943 onward. When the war ended in May 1945, T-34s were parked in the streets of Berlin. No Panther ever reached Moscow. The T-34 did not win the war on its own. No single weapon does. But the decision to make it simpler, cheaper, faster, and manufacturable by untrained workers in frozen buildings in the Ural Mountains is among the most consequential engineering decisions in modern history. Surviving examples can be found at the Kubinka Tank Museum outside Moscow, where a 1942 Ural production T-34 sits beside a restored Panther, and the contrast in finish quality remains visible to the naked eye even today. The Soviet tank looks rough. The German tank looks polished. The Soviet tank's descendants are still in service in dozens of armies around the world. The Panther's descendants exist only in museums. Kucherenko went back to his blueprint that December night in Nizhny Tagil, and he crossed out everything that did not make the tank fight. He crossed out smoothness. He crossed out finish. He crossed out the kind of mechanical pride that engineers feel when they look at a precisely made thing and know it is precise. He left the gun. He left the armor. He left the engine and the tracks and the basic hull form that made the T-34 dangerous. And then he handed the simplified drawings to workers who had been farmers 6 weeks earlier, and he told them to build as many as they could, as fast as they could, for as long as they were standing. They built them in the dark. They built them in temperatures that froze the grease in the track pins and split the skin on their hands when they touched bare metal. Teenage girls who had never seen a factory 6 months earlier learned to weld T-34 holes in the Ural winter, their faces masked against sparks and air so cold that the weld metal sometimes cracked as it cooled too fast. Workers slept on the factory floor between shifts because there was nowhere else to go and no time to go there. The plant ran 24 hours a day, 7 days a week, every week, from December in 1941 until the war ended. When a worker collapsed from exhaustion, another worker took their place. When a machine broke down, engineers worked through the night to fix it. When the simplified gearboxes failed in the field, tank crews learned to double D-clutch with both feet and a prayer, and they kept fighting anyway. The tanks those workers built rolled west. They crossed the same ground the Wehrmacht had crossed going east, and they did not stop. They drove through Stalingrad's rubble and across the Don Steppe and through the sunflower fields of Ukraine and into the Polish plains and across the Vistula and through the streets of Warsaw and finally into Berlin, where they stopped because there was nowhere further west to go. Nikolai Kucherenko was not in Berlin when the war ended. He was still in Nizhny Tagil, still at the plant, still standing over blueprints. The war had been won by the time he slept a full night again. He had made a tank worse and thereby made it better than anything the enemy could produce in sufficient numbers to matter. And that single act of deliberate, courageous engineering humility, the willingness to sacrifice pride for quantity, finish for function, perfection for presence on the battlefield in the thousands, that act had done more to end the war than any tactical genius, any brilliant general, any secret weapon ever conceived.